Welcome back to Math 107 College Algebra. In this video, we're going to take a look at how we can factor an arbitrary polynomial. So I give you x to the fifth plus 4x to the fourth plus 7x squared. I'm sorry. 7x to the third plus 7x squared plus 4x plus 1. We want to factor this. So the first thing we're going to look at is rational zeros. And as we investigated in class on Wednesday, we know that a rational zero has to be some number that divides 1 divided by some number that divides 1. So the only options that we have here are plus or minus 1. That usually will not be the case, but we're usually going to have more options than that. But in this case, we only have the 2. So we will start testing. I'll go ahead and start with 1. And I'll use synthetic division to test this. So 1, 4, 7, 7, 4, 1. Bring down the 1, multiply by 1, and add. 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 I get 24. So positive 1 is not a possible root. And I'm going to rewrite my list a little bit, make things a little bit more clear. So 1, we've eliminated as a possibility for being a root. So we'll now check out negative 1. So I'll use synthetic division again. So we'll bring down the 1, multiply by negative 1, and add. Multiply by negative 1 and add. Multiply by negative 1 and add. Continue that process. And this time I get a 0. So that tells me that I have this factoring as x plus 1 times x to the fourth plus 3x to the third plus 4x squared plus 3x plus 1. But now I'm not done. I still have more potential factors to check. Again, my end goal is to get this into something that's just a bunch of linear factors with possible complex coefficients. So now, I only need to check to see if stuff divides the fourth degree polynomial. And I still have, as the only possibility from the previous step, negative 1. So I will test negative 1 again. So 1, 3, 4, 3, 1. Bring down the 1, multiply by negative 1, and add. Multiply by negative 1 and add. Multiply by negative 1 and add. Multiply by negative 1 and add. I get 0 again. So now I've reduced the factorization to x plus 1 times x plus 1 times x cubed plus 2x squared plus 2x plus 1. And let's see if we can factor that cubic polynomial, or find a root of that cubic polynomial. Again, the only possibility I'm left with was negative 1. So I'll plug in 1, 2, 2, 1, bring down the 1, multiply by negative 1, and add. multiply by negative 1, and add, multiply by negative 1, and add, I get 0. So we now have x plus 1 times x plus 1 times x plus 1 times x squared plus x plus 1. So now I could go ahead and do the same thing again. Check negative 1 on this x squared plus x plus 1. Since we have a quadratic, we can find the zeros of that directly. So we'll use the quadratic formula. So you get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1, all divided by 2 times 1. So that gives me negative 1 plus or minus I times the square root of 3 over 2, which I will go ahead and take the liberty of rewriting as x equals negative 1/2 plus I square root of 3 over 2, and x equals negative 1/2 minus I square root of 3 over 2. So now I can plug those into the factorization, and I'm also going to condense this x plus 1 times x plus 1 times x plus 1 down into an x plus 1 to the third. Multiply that by x minus 1/2 plus I square root of 3 over 2. And I'll scroll over here. X minus 1/2 minus I square root of 3 over 2. So that is how we completely factor a polynomial of higher degree. We'll take a look at more of these in class and look specifically at, now that we know how to factor the polynomial, what can we say about the graph of the function?